All right, we are recording. So again, this is chapter 16. What this is it kind of brings, for lack of better words, kind of a closure to talking about object orientation. The first thing they'll talk about here is that it is totally possible and permissible to put more than one class into a file. Not only that, if you want to, you can have your main in the same file as your class. It's not recommended because it gets a little bit cumbersome, but you can do it. Then next, we're going to look at another type of documentation you can do. You all know that if you say // that the rest of the line in your .NET program is going to be a comment. You all know that if you start with a /*, you can have multiple lines and then with a */. You both should know that by now. The other thing that you may or may not know is when you start a comment line with 3 forward slashes, ///, that the comment, instead of turning green like it does in your editor, it turns gray. And then you can put in XML documentation. We haven't talked about XML documentation. We will, but not till the 4th semester because we use it a lot when we are working with Java. All right. Finally, they tell you how to create and how to use class libraries. Let's pretend for a minute that I wrote some kind of a generic class that would allow me to sort basically any kind of list that somebody passed into me. It could be a list of integers, it could be a list of strings, it could be a list of customers, it could be anything. What I can do then is I can take that code from that class and save it into what's known as a class library, and then bring it into any program that needs it later. All right, kind of like the same kind of an idea. A code library is kind of like the same type of an idea as a regular library. You go in there, you check out books in much the same way. It's not that you check out libraries, but you can grab them. .NET has their own libraries. You can create your own libraries. If you're working on a project with several people, you can each create your own libraries and even share them amongst you. All right, so that's a little bit of the beginning. Again, it's only about 16 pages, which I believe makes it about the shortest chapter in this book. So the author says in this topic, you'll learn how to organize applications that use multiple classes by coding more than one class per file. Guess what? You're already doing that. All right. Why? Because I didn't, even though in the book they have shown you, and you'll see it in here too, putting your class after main or before main, I think that to put those two things in the same file doesn't make any sense. Because like I said, all it does is it leads to confusion. All right. So the author says here, in most cases, you'll code each class that's required in a separate file. If 2 or more classes are closely related, however, you may want to store them in the same file. And that's what they show here. All right. These are 2 different classes that are stored in the same file. This is different. These are known as nested classes. With a nested class, you put one class inside of another class. And you might say, why would you want to do that? Because if you declare an inner class like this, it has access to all of its stuff and it has access to all of its parent stuff. So there may be a reason for doing that. Again, in the 4th semester, when we talk about the Android stuff in our last semester, we do work with inner classes. In here, I don't see the need to do that. So the author again says, when 2 classes are closely related, it may make sense to code them in the same file. And this is the key thing, especially if they're relatively small. All right. If they're of any size whatsoever, if they're 50 or more lines, even if they're closely related, it typically does not make sense then to code them into the same file. It just doesn't make sense to do it. It's not that you can't do it. It's just, like I said, it can get to be a little bit more cumbersome to work with that way. One way to code two classes in a single file is to code one right after the other, like we looked at here. Another way is to code them in a single file, is to put one class inside of another one. As it says, this is really only useful when the inside class needs to be able to use the information in the outside class. All right. And as it says, to refer to a nested class from another class, this is why it gets a little bit confusing. You might have to actually say the name of the first class dot the name of the second class. So the name of the outer class dot the name of the inner class. As I mentioned, this can get confusing. All right. Sometimes you want to go in the opposite direction. And what I mean is, you've got a class that's so large that you want to split it into multiple files. You can take one class and split that one class over multiple files. When you do that, each file is known as a partial class because you must put them together in order to be able to use them. All right, it says you code the word partial, which is a keyword, before the class keyword to indicate that the members of the class may or may not be split across multiple files. Then when you build the solution, the compiler will combine these partial classes into one class, and it does it behind the scenes, so you really don't even know that you're doing it. But as the author says here, if a class that you're working on becomes very long, or if you've got different programmers working on different parts of the class, you can use partial classes to split it up. So if I was working, let's just say that we were working on, I don't know, a payment class, but it was for, let's say, I don't know, Amazon. That might be so complex, it might not be, but it might be so complex that you have many different people working on it. And since you've got many different people working on it, you could break it up into a partial class so they could each have their own piece, so to speak. All right. Then they mention here, Visual Studio uses partial classes to separate the code that's generated from a form class from the code that's generated by the programmer. And we'll look at that example in just a second. Finally, C# also lets you code partial methods within partial classes. Partial methods are used to implement methods similar to events. What does that mean? Again, if it was something that complex that it needed to be put in multiple files. So you'll notice there's the first file and there's the second file. They look the same here and here. Public, partial, class, customer. But when the system goes and compiles the file, it combines the two of them together. So as far as as far as the system is concerned, it is only one file. All right. You may or may not have noticed this already from the stuff we've been working on. This is the file you work on. This is the file that Visual Basic, and I'm sorry, that C# and Visual Studio, not Visual Basic, that C# and Visual Studio build in the background. So as you add things onto a form, they get added onto this file. Why? Just so the system, it allows it to keep track of what's what, so to speak. Now, I'm not going to read this to you, but I'm going to leave this up for about 30 seconds because you should be reading it. It pretty much is the same stuff that I've just mentioned in the last few pages to you. All right. We've talked about namespaces. And the author says a namespace is a container used to group a group of related classes. It looks like a folder. All right. It says, for example, all the .NET frame layer classes for Windows are in the systems.windows.forms namespace. You've noticed, you've either, from almost day one, I had you using static space system.console. All right. And that was doing that. And what it was doing was it was saying, go out to the system, basically the system class, and underneath there, find the console class. All right. Every C# class you create must belong to a namespace. As it says, this namespace is determined by the namespace statement that appears near the beginning of your source file. And they will show you examples of that here. So here's code that declares a namespace. Here's a namespace within a namespace, which is legal. But again, you're both smart enough to realize this is a beginning course. And once you start doing stuff like that, that would be put into an advanced class, not in a beginning class. All right. And you can also say, here, what do we have? Basically, this is like this. But here we're saying we've got validation, which is inside of Muroc, which is basically what we have here. Remember, it's the using directive that you use with a namespace. So as it says here, a namespace is a container. It's used for grouping, just like a folder is used to group files that belong together. It's the same type of an idea. The namespace statement that appears at the beginning of a source file identifies the namespace that classes in that file belong to. As it says here, by default, when you add a class to a project, it's added to a namespace with the same name as the project. We just looked at the fact that these can be nested if you need to do so. To use a class in a namespace other than the one you're in, you must qualify it by putting in the namespace dot the name of the class. All right, documenting classes. I already mentioned this with the XML documentation. I may have given you this shtick already. Keegan, you may have heard this. Angie, you probably haven't, but back like, I don't know, it must be close to 20 years ago. It was I believe it was between 2000 and 2005. All right, people had said that, you know what, HTML is dead. We can't do anything else with it. It doesn't meet our needs. So they came up with a new language called XML. And the X that's in there actually stands for extensible. The difference between HTML and XML is with HTML, you've got a set of predefined classes and predefined tags. You all know what a doc type tag is, or maybe you don't, Angie, but you'll learn it next semester. But there's a set of around 100 to 125 predefined tags that are in HTML. They decided when they did XML, you as a programmer, you could make your own tags. All right. And why is that important? Well, think about it. If I'm a programmer and I'm talking with a carpenter, so I'm going to create some kind of a program that maybe, I don't know, maybe it's going to work with AI, artificial intelligence, or something else. And if that person puts a tag in there, the carpenter that says table, if it's a table tag, is that supposed to be a table that he or she is building out of wood with 4 legs? Or is that a table that holds information? That's where this can get really, really confusing. But if you want to be able to add XML documentation to your program, you put in, like I said, 3 forward slashes. Why would you want to do that? Because what it does is it builds a bunch of stuff in the background, and people who come in who have XML viewers can read that documentation. All right. So what's the difference between an XML comment and a regular comment? XML comments, for lack of better words, are kind of buried in the code more than an HTML comment. All right. And they're meant for, notice they go between summary tags because that's what they're for, is to kind of summarize what you're doing. How to view that, just mention this. All right. You can come in and actually take a look at and read the documentation. So it says it's also visible in screen tips that are displayed in the code editor. So if you highlight it, it's going to show you the information as well. All right. Finally, the last thing that's discussed in here, about 6 or 7 pages left in the chapter, are the concept, or is the concept, of class libraries. As they mention here, so far the classes that you've created as part of a Windows Form project have been the built-in classes. However, if you want to be able to use classes you create in a different project, you'll want to store them in a class library. So as it says there, simply put, a class library consists of a collection or set of related classes. When you use the library, you can use any of the classes in the library without having to copy them into your project. Now, what they show on here in the example that's in here is they're trying to show you the difference between these. Let me jump back. Okay. It says it shows the difference between using classes created in the Windows Form project and the ones you've created. The ones in the Windows Form project must be included in every project that uses them. In contrast, ones that you create exist separately from any project that uses them. So they're available to any project that wants to use them. And a benefit is mentioned there is the size of the project is reduced. All right. Again, it's like the difference between you going out and buying a brand new book when you need it, or you being able to either rent the book or go to a library and take it out for as long as you need it. Another benefit they say is it simplifies maintenance. If you make a change to a class in a class library and you recompile, that change will filter its way down to anything that uses that class library. But here's the big thing. This is really the hallmark right here of object-oriented programming. And it's called reusable code. And not meant to be funny, because it isn't funny, but I have talked before to managers, supervisors, etc. And when you put the word reuse in there, their eyes light up, because every time they hear about being able to reuse something, that means you're going to save money. So as the author says, if you design your classes carefully and place them in a library, you can reuse them in other projects that require similar functions. In most cases, you'll use the classes directly, but you may have to make changes. I think I mentioned to you, or hopefully I did, a week or so ago, that again, as an example, let's suppose that the enterprise rent-a-car that's across the hall from where our classroom is, let's suppose that they contact me and they say, hey, we want to do we're having problems with the way that we're renting our cars. We'd like you to rewrite our system for us, our car reservation system. So I do that, or we do that as a class. And it works just fantastically. Now, somebody finds out about it. Let's say that someone from Enterprise is friends with someone who works at a Holiday Inn. And they say, man, our reservation system is just really goofed up, the Holiday Inn person says. And the rent-a-car person says, hey, we just had this guy rebuild ours. Maybe he or they could help you. So they contact us, and we realize that we built the class in a generic enough manner that it can be used both for rent-a-car reservations and for hotel reservations, as long as we make a few changes. That's an example of using a class library. So as it says here on the bottom of the page, provides a central location for storing classes used by 2 or more applications. When you store the class in there, you don't have to include the class in each application that uses it. Rather, you create a reference into the class library in those applications. So you don't have to bring it in. Again, when you modify a class in a class library, the changes, as soon as you recompile, are immediately available to any application that uses the library. Finally, to create a class library, you develop a class library project. Then when you build it rather, the system creates a DLL. You may or may not have ever heard of that term before. DLL is Dynamic Link Library. And what it does is it's basically, for lack of better words, it's kind of like an executable file that you can plug in and use in any other file. So they show how to create. Oops. Oh, I'm going the wrong way. Sorry. They show how you can create a class library project on page 520. They talk about it, and they show it on page 521. All right. It says it's available from the new project dialog box. After you complete the dialog box, Visual Studio creates a class library automatically for you that by default is called Class 1. But you can rename it to whatever you want. You can put in whatever code you want to put into it. Then you are able to, since it's saved as a DLL, you can bring that project in to any other project. Now, you may get this, you may not. I'm not even going to ask, but guess what? You've used this already. Do you remember? And give me a yes or no when I finish this. Do you remember when we went into our C# programs and we added the ability by bringing in a Visual Basic input box? You both remember that?
Yeah.
Yeah.
We brought in a DLL, we brought in a class library that had that in it, and then we were able to use it in our program. That's the kind of thing. So again, the idea is it's something that you can use on an as needed basis that can not only save you time, but it can save you rewrite. All right. All right. I don't know if there's anything in there we haven't already talked about. So how to add a reference from a class library. So how do you take that class library and bring in a reference of it into your program? All right. You use that reference manager dialog box. I don't know. This is the one that very similar. Hopefully you remember this, but we had one with a bunch of stuff in here. I went into here and typed in Microsoft.Visual Basic right in there. It gave us a bunch of things, and one of the ones near the top was Microsoft Visual Basic. I checked on that. I clicked OK, and then it brought that reference into here. These are our dynamic link library or our reference files. All right. And then once we did that, I had to come into here and put in using Microsoft.Visual Basic. Then we could use that input box. It's very similar to the example they're giving here, but they're using something mythical with the Muroc.validation. But it's something we have looked at. So you should be able to look at the verbiage here and say, oh yeah, I kind of remember when we did that. All right. And that's it. Now, I do want to say one more thing. We're almost done here, but just before we do finish up, I'm going to stop this share and I'm going to start another one, but I want to see first, do I have this open? Yes, good deal. All right. So I'm stopping the share and I'm going to start another share here. And there it is. This is what I emailed you earlier today. It has 6 problems on it. Will we have time to do all 6? I don't know. Will we do some of them as a class? Partially, at least, probably. But take a look at this, not this second, but take a look at this by next Tuesday, the 31st. Because when we start going over examples, I'm probably going to have us do a simpler one ourselves when we build something. But we're eventually, by the end of the week, we're going to be going into this stuff. My hope is that a week from today, and we'll see how it works. A week from today, we're in April already. That either a week from today or a week from Monday, one of those two, I'm going to give you another pretest. And the pretest will be on inheritance and interfaces. We will go over that. Then either Monday the 6th or Tuesday the 7th, we will have the test on chapters 14 to 16, which would mean that probably that Wednesday we'll start on databases. That's the last topic we have. I actually really and truly think you'll enjoy working on that. All right, so we will go over chapter 17 and 18 and 23, and that's it for the book. But we'll also go through a bunch more examples. All right, we'll have one last project that we'll do, and we're probably going to end up doing it as a class. Any questions on anything that I brought up?
No.
No.
All right. Try to, if you can, by, let's just say no later than Monday. It was supposed to be today, but by no later than the beginning of class Monday, put all of your work for the non-object oriented problems from the chapters 1 through 12 lab, put them into a folder, zip the folder, and email it to me. I don't think it'll be greater than 5 meg, but if it is, if nothing else, send me 5 files. Just zip each project. Or we're not doing number 2, that store inventory. We'll go back and take a look at that at a later time if there's time. Does all that make sense?
Yeah.
Please make sure you do that because I'm supposed to be holding you accountable. All right. All I've done so far is I've looked at what you've turned in for those non-oops, and they were fine. All right. I didn't go in and upgrade your grades yet, but I will do that probably sometime this weekend. So if you have no other questions, feel free to drop off. I'll stay on as long as one or both of you are in here. Otherwise, I will talk to you on Monday. Have a good weekend.
Thanks. You too.
Thank you. All right, I take it there's nobody there. It's showing me nothing else. I'm going to stop recording. And when I stop recording, I'm going to leave the meeting.